Right now, light from distant galaxies is racing toward Earth, but most of it will never arrive. The universe is expanding so fast that thousands of galaxies are slipping beyond our reach every single second. Truth is, infinite looks empty because it's being empty. Besides, dark energy, an invisible force we hardly understand, is rupture the cosmos apart faster than the velocity of light. And there's nothing we can do to stop it. Here's the deal, hit that subscribe button if you're enjoying this journey into the void. We're about to witness the universe erasing itself. Prepare yourselves. We get down, what we're seeing is, truth is, look up at the night sky. Those stars dispel across the darkness. They're an illusion of abundance. Between every point of visible light lies an emptiness so huge that if you shrunk our full coltsfoot down to the size of a coin, the near galaxy would be posing 10 ft away. And between them, nothing. Absolutely nada. Usually we call it space, but that word's spirit too generous. Of course, this is not like the gap between cities or eve continents. Interestingly, imagine standing in the heart of a desert where the adjacent cereal of sand is 1,000 miles away. That's how empty the universe really is. Topic: everything we can see and touch makes up less than 1% of what's out there. The ease is vacancy. Think about it this way. Scientists measured this emptiness in visible radiation old age. 1 light-year equals just about 6 trillion miles. The norm distance between galaxy, 2 million light-year. That means if you could travel at the speed of light faster than anything physically possible, you'd still spend 2 million years crossing pure malarkey to scope the next island of thing. But here's what make it terrify. The thing is, space was none ever this empty. Obviously, after the Big Bang, matter was packed together, dense and hot. Galaxies formed close adequate to interact, to collide, to dance about each other. Then something altered. The universe started spreading apart and it ne'er stopped. Indeed, think of infinite ilka balloon being inflated. Galaxies are dots drawn on the surface. As the balloon expands, those dots move farther apart, not because they're traveling through space, but because space itself is growing between them. Every second, billions of cubic miles of new emptiness appear throughout the existence. This enlargement agency, the universe, is become emptier with each passing instant. Right now, as you listen to this, the nearest coltsfoot to us is rush away at 40,000 mph. We're not moving, it's not locomote. The emptiness between us is multiplying, clearly, and this emptiness is not inactive. It has weight. Scientists call it dark energy, and it brand up 68% of everything that exists. We cannot see it, cannot touch it, cannot find it directly. The reality is, we only know it's there because galaxies are fleeing from each other faster than gravity should allow. Here's the part that should make your skin crawl. Dark energy is acquiring stronger. The emptiness is growing faster now than it was 1 billion years ago. Faster than it was 1 billion years ago. What we're seeing is, honestly, the creation is not just expand. It's accelerating into limbo. But here's what's interesting. What does this intend for us? We dwell on a rock orbiting a ace in a galaxy swimming through an sea of aught, and that ocean is acquired deeper. Plus, every day I intend the island of thing impetus further apart. Definitely, every day the universe becomes more hostile to everything we recognize as real. But the emptiness is not the worst portion. What's truly terrorized is what's causing it to grow. In 1998, 2 teams of stargazers made a discovery that shattered physics. They were measuring distant supernova explosions, attempt to figure out how fasting the universe was expand. Every scientist expected the same answer. Expansion should be slowing down. Gravity pulling everything together, right? So, the world should be losing speed, gradually crawling towards some eventual chemical equilibrium. The telescope said otherwise. The universe was not slowing down. The reality is, it was speeding up. Galaxies were racing away from each other faster now than they were billions of years ago. Envisage throwing a ball into the air and watching it speed up upward instead of fall back down. That's how impossible this seemed. Scientists checked their calculations 3 times, 4 multiplication 10 times. But here's what's interesting. The math did not lie. Something was pushed galaxies apart with more force than graveness could resist. They call this force wickedness energy, but that's just a placeholder for we have no idea what this is. Generally, here's how fast we're talking. The most remote galaxies we can observe or move away from us at 98% of light speed. That's 655 million mph, and they're accelerating. In some other zillion old age, they'll be moving flush faster. The reality is, definitely, this break one of the fundamental pattern we thought governed reality. Einstein's equations suggested the existence should either expand and slow down or collapse rear on itself. A universe that expands faster and fast was not supposed to subsist. Yet, here we are living inside one. Consider about what acceleration means. When you press a gas pedal, you're adding energy. Think about it this way. In fact, the universe is pressing its own gas pedal harder every minute. Here's the deal, where is that energy coming from? Empty, infinite itself. Every cubic inch of nullity comprise a bantam amount of darkness energy. As space expands, more three-dimensional inches appear. More wickedness energy seen with them. The expansion feeds itself. Scientists measure this quickening using something called the Hubble constant. Indeed, it tells us how fast the universe is expanding right now. The number should be fixed, one universal fastness, but measurements keep giving different answers. Some methods say 67 km/s per megapark. This gap is called the Hubble stress and it's driving physicists mad. Why does this matter? Plus, because if we saw none agree on how fast the universes expand, we saw not foretell what happens next. Is the acceleration impermanent? Will it plateau? Or will it keep increasing until something breaks? The majority of grounds points to the worst option. Truth is, iniquity energy appeared to be a constant property of space itself. As long as infinite exists, darkness energy survive. As Uranus dark vigor exists, enlargement speed up. Naturally, there's no brake treadle, no off switch. Here's why this matters. We're passenger in a vehicle that's speeding up toward an unknown terminus, and the speedometer is broken. So, what precisely is this dark vigor tearing everything isolated? And here's the thing, think a force so effective that it overpowers gravity crosswise the total creation. Frankly, not just in one region, everywhere, all at once. That's iniquity vigor. And the strangest part, we saw and none see it, measure it direct, or even turn up what it's get of. We only cognize it exists because galaxies are fleeing, from each other when they should be pulled together. Believe of infinite like a textile. Matter creates dips in this fabric. That's soberness. A star makes a small dip. A colt's foot makes a larger one. A inkiness hole terror, a deep pit. These dips pull object together. That's why planets domain stars and star clustering into galaxies. Gravity is the force trying to hold the universe together. Dark energy does the opposite. It pushes the fabric apart, not by create hills pretty much, but by stretching the entire sheet in all direction at once. The more textile exists, the more stretching force look. It's like the creation has an intrinsic pressure built into empty space itself. Scientists have three brainy hypotheses about what iniquity energy actually is. The first is called the cosmogonic constant. Plus, Mastermind primitively proposed this in 1917, then name it his biggest error. The mind is simple. Empty infinite has vigor. Not much, about 1 proton worth of energy 3-dimensional meter. But space is space, so that tiny sum adds up to enough force to thrust galaxy apart. The second hypothesis is called ether. This proposed dark energy is not constant, it changes over time. Maybe it was weak in the past and will grow strong in the futurity. Or maybe it fluctuates ilk a wave pushing and pull. If quintessence is real, the universe's fate becomes even hard to predict. The third choice is the most disturbing. Our understanding of gravity is damaged. But here's what's interesting. Possibly Einstein's equations work perfectly on small scales, planets, stars, flush galaxies, but fail across cosmic distances. Perhaps there's no mysterious force at all. Mayhap infinite just doesn't behave the way we thought it did. Here's the problem. Besides, dark vigor make up 68% of the creation. Wickedness matter, some other invisible substance, accounts for 27%. Importantly, normal matter, ace, satellite, people, everything we can actually see is only 5%. We live in a universe where 95% of reality is unseeable and incomprehensible, and dark energy is win the cosmic battle. In regions where galaxy bunch sit close together, sobriety still dominates. These clusters will eventually blend into monumental supergalaxies. But everywhere else, darkness vigor is tearing construction apart. Look, the space between Coltsfoot clusters is expanding so fasting that they'll near interact again. Image two people standing on antonym sides of a river. The river keeps getting wider. What's more, at some point, even if they really scream, sound waves sun across the distance. Evening, if they shine flashlights, the light gets stretched and dimmed until it disappears. Plus, that's what's happening to galaxies. Think about it this way, they're float into isolation. So what does this mean? What makes dark energy truly terrifying is its posture. It's that we saw not turn it off. What we're seeing is, We cannot slow up it down. We cannot even understand it, basically, and it's rewriting the futurity of everything that exists. But some galaxies are already feeling its effects in disturbed ways. Right now, at this very minute, there are galaxies moving away from Earth faster than visible light can travel. Basically, not because they're breaking natural philosophy, but because the infinite between us is expanding so chop that even visible light can't keep up. Let's brand this concrete. The Andromeda Galaxy sit 21/21 million light-year away. It's the closest major Kurzfoot to us and in reality travel toward us due to sobriety. Think about it this way. Besides, but look beyond Japanese Andromeda, yesteryear our local anesthetic neighborhood, and everything is flee. The Virgo bunch, fundamentally 53 million light-year age away, recedes at 750 m/s. The Coma cluster, 320 million light-year remote, races away at 4,300 m/s. Go farther. The most distant galaxies we've ever observed sit 13.4 million light-year away. We see them as they appeared shortly after the Big Bang. No doubt, the light from these galaxies has been traveling toward us for almost the entire age of the universe. And yet, the galaxies themselves are now travel away at more than twice the speed of light. Think about it this way. How is this possible? Because they're not moved through infinite. Space itself is moving. Einstein's fastness boundary only applies to objects traveling within space. And here's the thing, but space itself can expand as fasting as it wants. So what does this mean? There's no cosmic speed bound on the fabric of reality. Picture yourself on a treadmill that's speeding up. You can run forward, but if the belt accelerate faster than your top speed, you'll relocation backward anyway. Galaxy aspect the same problem. Light leaves them travel toward us at maximum speed, but the space between us expands faster, carry those galaxy away. The light still reaches us eventually, stretched, dimmed, antediluvian, but the source is now impossibly remote. Scientists call this recession velocity. It measures how fast distant objects appear to move away due to cosmic enlargement. For nearby galaxies, recession is slow up a few 1c miles/s. Here's the bottom line. But double, pretty much, the distance and recession doubles. Triple the distance, corner triples, there's no upper limit. Obviously, this creates something called the cosmic view. Beyond a certain distance, galaxies recede faster than light travels. At the end of the day, obviously, their light will never scope us. Not in a billion eld, not in a trillion. Naturally, the space between us expand fast and fonts can cross it. Without question, those galaxies exist, but we'll never see them. They're cut off from our universe as completely as if they survive in a separate dimension. Basically, and here's the devastating part, that skyline is getting closer. Importantly, every second galaxy that were once visible mark beyond our range evermore. Here's the bottom line. Imagine watching Adept wink out of existence one by one, cognize their hush out there, but forever beyond observance. That's happening right now, just too slowly for us to notice. In 100 billion old age, every galaxy outside our local clump will have receded beyond the cosmic horizon. Future astronomers will look up and see a smattering of nearby galaxies surrounded by infinite darkness. They'll have no grounds that billions of other galaxies ever existed, no evidence of the Big Bang, no evidence that the creation is expanding. They'll consider they live in a small atmospheric static eternal cosmos. The thing is, they'll be wrong, but they'll have no way to know it. We were lucky. Surprisingly, we exist in an era when the universe still reveals its secrets. But that window is close when distant galaxies have not yet go away. And it's closing because we're trapped actually inside an invisible barrier we can near cross. Light speed is absolute, 186,000 m/s. Nothing move fast. Not molecular, not information, not even quantum entanglement. Honestly, this is not a technical limitation we might get over with better technology. It's woven into the structure of world itself. Einstein figured this out in 1905. His equations show that as objects approach light speed, strange things happen. Clip slows down, batch increases, energy requirements skyrocket. Here's the bottom line. To accelerate even a single atom to light source velocity would require infinite energy, more energy than exists in the entire universe. At the end of the day, this speed limit does not just affect spaceships, it affects everything. Soberness propagates at light fastness. Electromagnetic radiation travels at light fastness. Also, even causality, cause and result is restricted by light velocity. Frankly, if you could some ways move faster than light, you'd come before you left. Notably, past times and hereafter would collapse into paradox. For interstellar travel, this create a nightmare scenario. At the end of the day, the nearest Maven system, Alpha Centauri, sits 4.3 light-years away. If we built a space vehicle that could travel at 90% of light fastness, far beyond anything remotely possible with stream technology, the journey would return almost 5 age, even, and that's just to the 9 neighbor. Generally, most stars in our galaxy sit thousands of light-years away. Other galaxy millions or billion of light-age remote. At light velocity, you could cross the Milky Way in 100,000 eld. You could reach Japanese Andromeda in 2 million years, the edge of the observable sort of universe 93 billion light-year. To be honest, evening light source itself sun aren't traveling fast enough to explore what's out there. But here's where it get worse. Without question, remember, the world is expand, and here's the thing, that expansion adds velocity to the distance light must travel. Interestingly, a galaxy 10 million light-years away isn't sitting still. It's racing away from us at hundreds of 1,000 of miles per second. Visible light from Earth would have to catch up to it like a runner chasing a car on the highway. For nearby galaxies, light source can hush-shuffle the journey. The enlargement is slow up enough, but yesteryear a sure distance about 15 billion light-years. Expansion outraces light. Photons going Earth right now will never reach those galaxies. They'll travel evermore through expand infinite, acquiring farther from their destination with each lost second. This creates a boundary called the cosmological event view. Actually, it marks the limit of where quite we can hear direct signals or info. Anything beyond it is permanently cut off from us. We cannot send messages there, we cannot traveling there. We cannot affect or interact with anything past that line in any way ever. And that line is acquiring finisher. As the universe expands faster, the event horizon shrinks. Galaxies that used to be inside range slip beyond it. Also, 5 billion years from now, the view will be finisher than it is today. 10 billion years from now, closer hush. Finally, only our local clump of galaxy will remain interior our reachable existence. Consider about what this means. Indeed, 99.9% of galaxies that exist right now are already beyond our scope. We can see them. Surprisingly, their ancient visible light is still arriving, but we can never visit them, never put across with them. If well-informed life exists in those galaxies, we'll near know. Frankly, they're seeing the same problem from their side. Look at us, forever separated by infinite that expands too fasting to cross. We're not just limited by engineering, we're imprisoned by the laws of physics themselves, and the walls of that prison are closing in. What we're seeing is, certainly, but even the galaxies we can hush see are about to disappear from view forever. Think looking up at the dark sky 100 zillion years from now. Frankly, you'd see a fistful of galaxy, really, maybe 30 or 40, dispel across the darkness. Everything else proceed, not destroyed, not dead, just unseeable, carried so far away by cosmic expansion that their visible light can no longer bridge the gap. This is not speculation. When galaxies will vanish from our view, astronomers have worked out exactly. The process has already get down. Right now, we can observe roughly 200 billion galaxies across the creation. Honestly, that number sounds enormous, but it's a tiny fraction of what actually exists. In fact, for every galaxy we can see, countless others sit beyond our cosmic view, their visible radiation forever unable to reach us. The mathematics is straightforward but barbarous. Light travels at space expand at an accelerate charge per unit. At some distance, enlargement win. Often, the space between us and a galaxy grows faster than visible radiation can mark it. So, what does this mean? Photons' departure that Colt's foot right now will traveling toward us for billion of years. Devising procession getting closer but never quite arrive because the finish line keeps travel away fast and they can run. But here's what's interesting. Usually, here's how the disappearance unfold. First, the most remote galaxies slice from seen. These are the ones sitting near the edge of our observable creation, already locomote away at nearly light velocity. The thing is, as space stretched the wavelengths until the photons arrive so infrequently that even the most sensitive telescopes can't detect them, their light source grows dimmer and redder. These galaxies do not blink out, they fade like a sunset, gradual and inevitable. Next, galaxies closer to place outset vanishing. Not because they're physically locomote away fast. Sometimes, cosmic enlargement affects everything every bit. Also, but because time keeps departure as billions of years roll by, the cumulative outcome of enlargement grows. Galaxies that once sat inside our range cross beyond the point of no return. Their visible radiation stops arrive. Their existence becomes unprovable. Scientists have mapped this timeline. In 150 billion old age, every galaxy beyond our local supercluster will have disappeared from view. Notably, the Virgo supercluster, placed at thousands of galaxies across 110 billion light-year, will be the last major construction we can detect before the darkness closes in. But even Virgin will not last forever. Finally, darkness zip will rip isolated even large gravitational structures. Galaxy bunch will disperse. Individual galaxy within our local anesthetic radical will remain visible, but everything else vanish. The night sky become a void punctuated by a few 12 familiar neighbors. This create a horrifying scenario for any civilization that power arise in the far future. ID being an astronomer million of years from now. You'd look up and see a small, seemingly eternal collection of galaxies. No evidence of the Big Bang. The thing is, its radiation would be too weak to detect. No evidence of cosmic expansion. Null visible to amount it against. No evidence that, the universe was ever diverse than it appears right now. You'd form theories about your static, unchanging cosmos. All of them would be wrong, but you'd have no way to cognize that the truth of the existence, its origin, its expansion, its ultimate fate would be totally hide from you. Really, not because the evidence was destroyed, but because it withdraw beyond watching. We survive in a brief golden age, a cosmic moment when the universe indicates its nature. Certainly, when we can investigate the afterglow of creative activity itself, that window is shutting when remote galaxies still shine in our telescopes. Basically, hereafter civilizations will inherit a dark, emptier sky. Usually they'll face up and see loneliness, and actually they'll have no idea how much they're missing. The reality is, picture this. You're bare on Earth, essentially 1 trillion eld from now. You grow up looking at a night sky containing exactly 34 galaxies. And here's the thing, that's it. What's more, no remote clusters, no quasars, no cosmic web of construction stretch across billions of light years, just 3 12-island galaxies floating in an ocean of honed blackness. You become an astronomer. You study those galaxies meticulously. You step their positions, their movements, their compositions. Certainly, over decades of observation, you notice something unusual. They're all drifting closer together. So, what does this mean? Soberness is pull them and bound. You conclude that the creation is contracting. Indeed, that everything visible is descend toward everything else. You'd be wrong, but you'd have no grounds to prove it. Honestly, the creation would not be contracting. The truth is, it would still be expanding faster than always. But the only galaxies you can observe are the ones bound together by gravity into our local anesthetic cluster. These galaxies area each other immune to cosmic expansion because their mutual gravitational pull is stronger than dark energies push to you. They look ilk the stallion universe, and they ba ba ba. You'd never observe the Big Bang's cosmic microwave ground. It would still exist, but stretch and cool by trillions of years of enlargement until its temperature sits just a fraction above absolute nil. What's more, your instruments could not really distinguish it from empty space. You'd have no evidence the universe had a beginning. You'd never mount cosmic expansion. All the galaxies fleeing from each other at impossible velocity gone, vanished beyond your cosmic horizon. Honestly, the only galaxies left in view are the ones coming finisher, making it seem like the universe is catching or atmospherics. To be honest, you'd never see distant supernova. The A-set proved dark energy survive in the number 1 place. But here's what's interesting. You develop hypothesis about gravity, affair, vigor, all based on incomplete information. Your physics would work for what you can see, but it would miss the larger truth completely. This is not science fiction. This is the actual hereafter awaiting any civilization that arises belated in cosmic account. Uranologists in that era will look at the same universe we study, but they'll see something entirely different. On top of that, not because the universe changed its rules, but because observable world depends on when and where you exist. At the end of the day, scientists call this cosmic censorship. The universe hides its yesteryear from future observers. Not through malice, but through expansion. The grounds does not disappear. It just recedes beyond the speed of light barrier, becoming forever unreached. Here's what makes this terrifying. We power be go through the same job right now. Indeed, maybe there's grounds of an big truth that's already vanished beyond our cosmic purview. Maybe the universe went through earlier phases that we can never observe because their visible radiation has been outrun by expansion. expansion. Honestly, maybe what we think is the complete story of the creation is actually just one chapter in a much longer story. We can see 13.8 billion years into the past or some to the Big Bang itself, or at least back to what we call the Big Knock. What if that was meant the outset? What if something happened before, but the evidence has already withdrawn beyond detection? We'd be just ilk those future astronomers studying an incomplete picture and thinking it's everything. Sometimes, this is the cruelest aspect of cosmic expansion. It doesn't just separate galaxies in infinite. It separates civilization crosswise clip from the truth of their own universe. Every cobbles of astronomers sees less, knows less, can prove less. We're living in one of the last eras when the existence is still knowable. Besides, when its root, its structure, its fate are all hush visible in our telescope. Of course, in the far hereafter, that gnosis vanishes, not because civilization forget it, but because the universe itself wipe out the evidence and the procedure has already begun. Right now, as you hear these words, we're trapped inside a shrinking house of cards of knowable space. Base exterior on a clear dark, look up. In fact, every star, every coltsfoot, every photon of visible radiation reaching your eye come from interior A orbit. No doubt that area is the observable creation, and it has a hard bound. Frankly, beyond that border, galaxies survive. Stars burn, planets orbit, but their light will near range us. Not in a billion old age, not in a million, not in a million, ne'er. The bounds sit 46.5 billion light-year away in every way, not 13.8 billion. That's just how long light source has been traveling toward us. The actual distance is greater because the world spread out while that light was in transit. Picture a runner on an spread out track. By the time she reached the finish line, the starting point has moved farther back than where she began. Also, but here's where it gets strange. That edge is both real and fanciful. Real because it marks a genuine boundary. Nothing beyond it can affect us. Basically imaginary because there's nothing special about the location itself. An observer in a galaxy at the bound of our evident universe has their own sphere centered on them. Their discernible universe overlaps with ours, but broaden into regions we can never see. Conceive of it like standing on an island in fog. You can see tear smiles in every direction. That's your visible world. Someone standing 3 mi away has their own circle of visibility overlapping yours, but revealing shoreline you saw and observe. To be honest, neither of you is at the center of anything special. You're both just standing in fog, except the cosmic fog is expanding, and as it expands, your visible range shrivel up. This seems backwards at first. The universe is getting bigger. Should not we be able to see more? But the expansion is accelerate. Light from remote galaxy has to mark an ever-growing distance. Eventually, expansion outweighs the light source. Sometimes, galaxies slip over the border of our area and vanish from view. On top of that, the evident universe has been shrinking for billion of eld. Not shrinkage in the sense that the edge is acquiring closer. Truth is, it's actually getting further away in absolute distance, but shrinking in the number of galaxies we can observe. The reality is, every day, more galaxies cross the threshold where their light can no yearn or reach us. The population of our visible universe is dropping. Right now, we can observe approximately 200 million galaxies. Naturally, in 50 billion years, that figure be to 100 billion. In 100 billion age, it drops to 50 zillion. The observable universe becomes small and empty with each passing approach. And here's the portion that should brand you deep uncomfortable. We have no idea how large the actual universe is beyond what we can see. It might widen another 46 billion light-year and then stop. Or it might be infinite, stretching evermore in all direction with no edge whatsoever. We saw not cognize. Look, we're trapped inside our observation sphere with no way to peek beyond it. Some physicists estimate the entire creation is at least 250 times bigger than the observable part. Others suggest it's space. Both possibilities are equally unknown. A existence within border raises the question, what's beyond it? A existence without an edge raises the question, how can something have no boundary? Plus, either way, we're trammel. The observable creation is our prison house cell and the wall are closing in. Not rapidly. The process takes billions of years. But inexorably, every cosmic tick of the clock, more galaxies slip away, more stars vanish. More of reality becomes unreachable. You might think, so what if those galaxies are, so far away that visible light sun and scope us anyhow? They're not relevant to our beingness. Of course, but they are because hidden in those unapproachable regions might be answers to questions we saw none solve. The nature of dark vigor, the get-go of the universe, whether our kind of physics is complete or just an approximation that break down at big scales. We're trying to solve a puzzle while pieces of it fall off the table faster than we can grab them. And we saw, and we... but the shrinking edge is not the only thing trapping us. We're as well confined by something far more absolute. Look, here's the truth about our cosmic prison. We saw not leave it. Surprisingly, not with better rockets, not with Koval's ships, not with any engineering we could ever conceivably establish. The observable universe is not just the region we can see, it's the part we can ever interact with in any way. Honestly, and that part is surrounded by an impenetrable wall. That wall is causality itself. Information science and travel faster than light. Reason and result are limited by light speed. Really, this means any galaxy beyond our cosmic horizon power as well exist in a separate world. We cannot direct signals there. On top of that, we cannot receive signal from there. We cannot affect it and it cannot affect us. The connection is permanently severed. Let's make this concrete. Here's the bottom line. Honestly, the Andromeda galaxy sit 2.5 million light-years away. Let me put it this way. Wildly optimistic with stream engineering, it would reach Japanese Andromeda in 5 million years if we launched a spacecraft tomorrow traveling at half the speed of light. Difficult, but theoretically possible. Now consider a galaxy sitting 15 trillion light-years away. It's receding from us at over 90% of light speed. If we launch the same spacecraft toward it, what happens? The trade would travel forward at 1/2 visible light velocity, but infinite between us and that galaxy expands faster. The space vehicle make progress, locomote away from, basically Earth, but the terminus race away faster. What's more, the gap widens despite the craft's forward gesture. It's like running play up a down escalator that's moved faster than you can climb. You're running as hard as you can, devising all the right movement, but you're going backward anyway. Now, here's where it gets good. That spacecraft could travel for billions of years and near get closer to its target. Importantly, this create a essential limit on where we can go. Not a limit based on technology, but on natural philosophy itself. Just about 94% of the evident universe is already beyond our reach. Basically, we can see it in our telescope. Antediluvian light still arriving, but we'll ne'er visit it. Those galaxies are receding faster than light can chase them. Here's why this matters. Also, the remaining 6%, the local anesthetic universe within a few billion light-years, is theoretically approachable, but that region is shrinkage. As cosmic expansion accelerates, more nearby galaxies cross alignment into unreachability. In 5 billion years, the Milky Way and Andromeda will merge into a single supergalaxy. That combined structure, along with about 50 smaller galaxies in our local anesthetic group, will rest gravitationally bound. Sometimes, everything else vanishes beyond the wall. In 100 billion years, our topical anesthetic grouping will be the only matter we can interact with. We'll be restrained to a house of cards containing perchance a few dozen galaxies spanning a few million light years. Let me put it this way. Beyond that, infinite expansion, galaxies fleeing fast than we can follow. Signals that can ne'er be direct or received. Future civilizations in our galaxy will aspect out and see a small cluster of neighboring galaxies. Honestly, they power marvel what lies beyond. Often, they'll point their telescopes into the darkness and find no, not because nothing is there. Million of galaxies exist, but because causality has severed the connection. Think about what an agency to be permanently cut off from 94% of reality. But here's what's interesting. It's not like being on an island where you might establish a boat someday. It's ilk being in a creation that's splitting into fragment, each fragment drifting away from the others fast and light itself. Here's why this matters. You can watch your neighbor fragments retreat into shadow knowing you'll never scope them, no affair how long you try. We're living through the moment when the universe fractures. Really, when one unified existence breaks into countless causally disconnected regions. The walls of our bubble are already hard. Generally, they're just far decent away, kind of, that we do not feel confined yet. And here's the thing, but we should tone confined because there's something out there in the shadow and we being forced toward it against our will. Turn on a flashlight and point it at the sky. Of course, those photons will traveling forever crosswise the solar system, between the stars, through the Milky Way, out into intergalactic space. They'll keep move at visible light fastness for billions of old age, and they'll never arrive anywhere. This is the reality of cosmic enlargement. Visible light going Earth right now is headed toward remote galaxies, but most of those galaxies are receding so fast that the light will near catch up. Surprisingly, imagine a photon going our planet today, traveling toward a Colt's foot 15 zillion visible radiation eld away. Surprisingly, that photon moves at light speed, but the space between here and there expands faster than light can cross it. Often, the photon makes progress, get further from Earth, cross millions of light source years, and yet the destination keeps receding faster, staying forever out of range. Now flip it around, galaxies beyond a sure distance are shining light toward us right now. That visible radiation is traveling at maximum speed, head straight for Earth. On top of that, it will never arrive. The infinite between us expands too quickly. Those photons are pinned down in an expanding nullity, making progress, but never closing the gap. On top of that, they'll traveling through space for the total remaining lifetime of the universe without ever reaching us. This creates something deeply strange. There are galaxies that exist that are real, that are presently shining brilliantly, but we'll never see them. Not in any scope, no matter how efficient. Not in any wavelength of visible radiation, not through any trick of physics. No doubt, they're for good invisible to us, not because they're too dim or too far, but because the light source they emit can never bridge the expanding infinite between us. Consider about what this means for first physical contact. Plus, if well-informed living exists in those galaxies, we'll never know. They could be broadcasting wireless signal, edifice megastructure, lighting up their total galaxy with fusion torches. None of it matters. Their signals travel at light speed, and light speed is not fast enough. Also, the messages exist, propagating through space, but they'll never deliver. Worse, they're likely trying to range us. Any civilization advanced enough to broadcast signals would eventually point their telescope at galaxy like ours. They'd see our type of ace, our type of galaxy, and think, maybe someone is there. Certainly, so they direct a message beam straight at us with perfective accuracy. In fact, and that content would travel through spread out space for trillions of ELD without ever arriving. We'd never hear it, never know it was sent, ne'er have any evidence those beings exist. The same applies in reverse. If we direct signaling toward the most distant galaxies right now, those transmissions would be doomed before they left wing Earth. We'd be shouting into an expanding vacuum, our voices eternally unheard. But here's where it gets truly disturbing. Scientists' estimation there are 2 trillion quite galaxies in the observable universe. That's all the galaxy we can theoretically see if we had perfect telescope. In fact, but that number only includes galaxies whose visible radiation has already reached us or will range us someday. There are countless other galaxies beyond the cosmic skyline. Galaxies that survive, that have always existed, but whose light will never range Earth under any circumstances. How many? We saw net no. Maybe 10 trillion, maybe a 100 red trillion, maybe an infinite number. They're out there right now forming stars, possibly harboring living, exist in the same infinite in time as us. Definitely, on top of that, they are cut off from our creation as completely as if they inhabited a distinct dimension. Look, the existence is partitioned into causally disconnect regions. Naturally, each area comprises galaxies that can interact with each other, but not with galaxies in other regions. We live in one such region, a bubble of galaxy whose light can still mix and mingle. Beyond our bubble, other bubbles, other collections of galaxies, evenly real number, every bit crucial, but ever more beyond our reach. This agency, when we talk about the universe, we're really only talking about our topical anesthetic region of it, our cosmic bubble. Look, the real number creation, the full existence, basically, is vastly larger and most entirely unknown to us. Here's the bottom line. Honestly, we're like a fish in a pond trying to understand the sea. We can assess our pool in detail, but the ocean stretches beyond and shipway we can't even begin to step. And our pool is being ruled by an unseeable tyrant pulling everything toward an unknown terminus. The Milky Way is moving, not just expand with the universe, actively traveling through space at 370 m/s. Notably, that's roughly 1 million MPa. And it's not moving willy-nilly. It's being drawn towards something. Scientists observed this motion in the 1970s. Definitely, they were functioned the cosmic microwave background. The afterglow of the Big Bang anticipated to look perfectly uniform. Instead, they set up a dipole pattern. One side of the sky appeared slightly warmer, the other slenderly cooler. This wasn't random. Surprisingly, it meant we were locomoted through infinite fast enough to create a Doppler shift in the antediluvian radiation. The obvious question, moving toward what? Certainly, uranologists traced the direction of our motion and found something alarming. There's a region of infinite about 150 billion light-year away where tens of thousands of galaxies are converging. Truth is, all of them forced by tremendous gravitational force toward a single location. Notably, scientists named it the Great Attraction. Here's the disturbing portion. We can't see it. The Great Attractor sits behind the zone of avoidance, a thick lot of dust and gas from our own galaxy that blocks seeable light from distant objective. Infrared and radio telescope can peer through the dust. Disclosure monolithic coltsfoot clump in that way. Generally, but the total mass visible does not explicate the gravitative pulling we're experiencing. Something is out there. Something with roughly 10 quadrillion times the mass of our galaxy. Obviously, we're being forced toward it like water circle a drain, and we have no idea what it actually is. Some scientists think the Great Attractor is just a compactness of wicked wickedness topic, an invisible clump of gravitative mass that does not shine, but pulls everything nearby toward it. Others suggest it might be a supervoid, fundamentally a area where infinite expanded differently create a gravitative wake that pulls matter inward. The most disturbing hypothesis, the Great Drawing Card, power be a precursor to a future collision event. Tens of thousands of galaxies converging on a single point finally create a supercluster of incomprehensible scale. What's more, but wait, it get unknown. In the 1990s, astronomers discovered we're not just being pulled toward the Great Attraction. The thing is, we're being pulled yesteryear. There's something flush bigger, even further away, exerting influence across even more mind-boggling distance. They call this the Shapley compactness. A supercluster contains more than 8,000 galaxies. It sits 550 million light-years away and contains about 10,000 multiplication the mass of our galaxy. Think about the scales involved. Truth is, we are one galaxy among 200 billion in the observable universe. We're part of a local anesthetic radical containing about 50 galaxies. Besides, that grouping belongs to the Virgo supercluster, which contains about 100,000 galaxies, and our entire supercluster is being pulled toward the Shapley compactness ilk debris in a current. Plus, this shows us something terrorized about cosmic structure. Matter is not distributed evenly. There are regions of incredible density. Superclusters incorporate thousands of galaxies separated by vast nullity where almost nothing exists. And these density differences create gravitative flows. Definitely matter flow from low-density regions toward high-density regions like H2O flow downhill. We're catching one of those flows. The Milky Way, Andromeda, and all our neighboring galaxies are falling toward a supermassive concentration of matter century of million of light years away. We move at over a 1 million miles hour. Generally, and we've been falling for million of years. Usually we might continue fall for billion more before we range the terminus. What happens when we arrive? Nobody knows. Maybe we will SETI into sphere about the Shapley concentration, becoming part of its gravitational structure. Maybe we will pass through and continue onward, pulled by even larger structure we have not discovered yet. Or maybe, just possibly, cosmic expansion will finally overpower the gravitative attraction, going us eternally falling toward a destination we can near reach. The most unsettling facet of the Great Attractor is not the pulling itself. And here's the thing. The thing is, it's a realization that galaxies are not haphazardly scattered through space. They're caught in visible current, flowing along predetermined paths carved by gravity and dark matter. As insulate, autonomous, free to chart our own course through the cosmos, we like to conceive of ourselves. But we're not. We're being forced toward alien destinations by force vastly bigger than ourselves. And between the currents, in the spaces where null flow, there exist regions so empty they interruption our understanding of reality itself. Sometimes, imagine an area of space 1 billion light-years crossways. Inside that sphere, count the galaxies. In a typical part of the universe, you'd find roughly 10,000 galaxies. Ace, planets, gas, rubble, dark topic, all the common cosmic ingredients. Now, imagine the same domain somewhere else. You count the galaxies again. Besides, this time you actually find 10, not 10,000. Here's the deal, 10 total galaxies scattered across a billion light-years of emptiness. The rest is just void. No stars, no planets, no gas, pretty much nothing but space expanding into more space. Let me put it this way. These regions exist. Astronomers call them cosmic voids, and they're the largest structure in the cognized existence. They're not empty in the sense of perfect vacuum. A few galaxies do live within them, usually small and dim, but compared to the rich galaxy cluster that surround them, void are essentially barren. 95% of space sit inside these empty parts. The typical nullity span roughly 150 million light-years crossways, but some are much larger. The biggest known vacuum named the Iridanas supervoid reaching 1 billion light-years in diameter. If you stood at its center and looked in any direction, you'd see most aught. Interestingly, the nearest galaxy clustering would be century of millions of visible radiation eld away. Plus, you'd be surrounded by shadow. So complete that you could travel at visible light, sort of speed for 30 million years before reach the edge. Here's what makes voids so disturbing. They should not live according to our best models of cosmic construction. After the big knock, matter should have spread out relatively evenly. Graveness would cause slight clunking regions where matter bunched together into stars and galaxies. But the clumping should be mild, small-scale clustering with smoothened transitions between dense and thin regions. Here's the bottom line. Besides that, pretty much is not what we see. And here's the thing. What's more, we see a cosmic web, long strand of galaxy clusters stretching across one sea of million of visible light years surrounding vast bubble of emptiness. The existence looks ilk foam or Swiss cheese. Notably, thick wall of matter enclosing hollow voids. Importantly, this structure is too organelles, too extreme. The density differences between the filament and the voids are larger than early universe models predicted. Scientists have theories about how void organize. The first suggests their part where dark matter and normal topic happen to be slightly less dense shortly after the Big Bash. As gravity pulled matter together elsewhere, these underdense regions became empty. Matter flowed out of them like H2O draining from high ground, departure behind deserts of space. Certainly, the second hypothesis proposes that nullity are repeller zones. Without question, iniquity vigor doesn't just spread out infinite uniformly. It pushes matter away from certain regions and toward others. Voids mark the places where dark energy's repulsive force is strongest, actively ejecting matter toward the denser filaments. The third possibility is the most unsettling. Maybe void are places where matter near formed. Mayhap they're places where matter used to live but was go through. Imagine primordial inkiness holes. Here's why this matters. Inkiness hole formed soon after the big kind of bang, gathering in sure region and devouring everything about them. Eventually, these black holes would evaporate through Hawking radiation, leaving Earth's empty space with no trace of what passed off. Plus, no matter which theory is correct, voids are growing. As the universe expands, the empty regions get emptier. The few galaxies currently inside voids are slowly float toward the walls. In billions of years, even those stragglers will union the filaments, leaving the voids entirely barren. This creates a disturbing vision of the universe's hereafter. All matter will finally cluster into contract filaments and walls, separated by expand nullity that bear null at all. The universe will resemble a vast empty arena with thin threads of matter stretched crossways it. Generally, the nihility will dominate, devising up 99% of infinite. The affair will be trammeled to 1%. And here's the part that should chill you. Often, we live in a relatively dense region. The Milky Way sits interior the Virgo supercluster surrounded by thousands of other galaxies. We look up and see a sky full of stars because we inhabit a cosmic city. But most of space is not like this. Most of infinite is void. The reality is, if world had organized inside one of these empty area, our ancestors would have looked up and seen almost nothing. No doubt, a handful of dim galaxies, vast darkness. They would have assumed the world was small and lonely because their position make it look that way. We are lucky to live where matter exists, but that luck is impermanent. As cosmic expansion continues, even our local cluster will turn increasingly isolate. The nullity will turn, the filament will thin, the darkness will close, quite in and in sure directions. The shadow already hides something inexplicable. In 1977, astronomer Robert Kirshner was mapping galaxies in the constellation Boas. Here's the bottom line. He anticipate to discover the usual dispersion, clusters of galaxies dispel across the sky, roughly evenly spaced. Instead, he set up a hole, not a small gap, not a minor underdensity, a spherical part 330 million light-source years across, containing nearly no galaxies whatsoever, where there should have been approximately 10,000 galaxies. Look, he found 60 dissipate specks of light in a void, so pretty much large you could fit the Milky Way inside it 2,000 times. The boat is void, later nicknamed the Great Nothing Cadaver, one of the most perplexing structure in astronomy. Notably, it's not the large vacuum we've discovered, but it power be the empty. The Coltsfoot denseness inside is 10% of what it should be. 90% of the matter that should exist, there's simply lose. Let's put the scale in perspective. Light take 330 million age to mark the boat's nullity. When the first dinosaur appeared on Earth, you'd be about 3/4 of the way crosswise right now if you started traveling through it at visible radiation velocity. The void is so considerable that dozens of galaxy superclusters could fit inside with way to spare. And yet, it's almost absolutely empty. The few galaxies that do exist there are small, dim, and widely separate. What's more, most of them cluster come on the boundary as if they're trying to escape. The interior is just darkness and expanding space. The disturbed question, where did the matter go? When astronomers model galaxy shaping, they input the tightness fluctuations measured in the cosmic microwave oven ground, the old light in the world. Besides, these fluctuations state us how thing was distributed soon after the Big Bang. The model predict voids should subsist more or less, but nothing as extreme as betas. There should be at least 5 times more galaxies interior than we actually observe. 3 possibleness live. First, the matter is hushed there, but it's dark. The missing galaxies near organized stars. All their matter collapsed into iniquity structures, black holes, failed galaxies, massive clouds of cold gas. This seems unlikely. Star formation is efficient even in the emptiest region of space. At least some ace should ignite minute the matter left. Sobriety from surround structures pulled galaxies out of the void toward denser part. Over a billion of years, the void empty itself as a fair flow toward the walls. On top of that, but this doesn't amply explain the extreme underdenseness. Even with useful drainage, more galaxies should remain. On top of that, Tierce, actually, the affair was never there in the number one spot. The Boris's void marks a region where the Big Bang's initial distribution of matter was unusually uniform. No clumps, no density fluctuation, just smooth, featureless space with no gravitational seed, no galaxy formed. This theory Lucifer observation better, but it waged high new questions. Why would one region be so different from all over else? What made that speckle of early universe special? And here's the thing. Some cosmologists suggest void-like Botitus are grounds that our model of the Big Bang are incomplete. Usually, maybe the universe didn't start with tiny random fluctuation that grew into galaxies. Maybe there were larger structures nowadays from the beginning, vast regions of high and low density carved into space before ACE ever formed. Others marvel if voids are scars from an earlier era. If the universe traveled through a previous stage before the Big Smash, a collapse or bounce or transition, voids might mark places where zip drained away during that event. They'd be cosmic wounds that ne'er healed. The most unsettled possibility void are maturation, not just expanding with infinite, but actively go through matter. Darkness energy's repulsive force might be stronger interior voids. Force galaxies outbound fast than they can be pulled rear by gravity. Basically, if this is true, then voids are not just empty, they're acquiring emptier and they're spreading. We can test this. Measure galaxies near vacancy edges. Course their motions over time. If they're being pushed away from the vacancy center, fundamentally we'll know the emptiness is active, aggressive, infectious. If their descent toward the wall, voids are passive, just regions that start out empty and stayed that way. Either way, the boat's void force us to confront an uncomfortable truth. The world is not just expanding, it's fragmentized. Usually dense regions cluster together while empty regions remain empty. Certainly, matter dressed ore into smaller and smaller volumes of space, while the void turned large. No doubt, the universe is sorting itself, separating affair from emptiness, light from darkness, and the operation power be accelerating faster than we ever imagined. And here's the thing, the nihility are not atmospherics. They're not fossil remnants of the early universe that have remained unchanged for billions of eld. They're live, growing, go through the space about them, ill cancerous bubbles expanding through tissue. Here's how it works. Here's the deal, picture a void with galaxy cluster about its edges. And here's the thing, gravity pulls those galaxies together, devising the clusters denser, but gravity has a restrict range. Beyond a certain distance, its pull becomes weak. Certainly, dark energy, meanwhile, operates everywhere. Inside the void, there's essentially matter to counteract wickedness energy's detestable force. The truth is, the space expands faster there than in denser part. Over clip, this creates a feedback loop. The void expands, its enlargement pushes nearby galaxies outward. Those galaxies drift toward existing clusters at the nullity's border, making the clusters denser while leaving the void flush empty. The truth is, certainly, the hollow the vacancy become, the faster it expand. The faster it expands, the more it pushes galaxies away. The cycle accelerates. Scientists measure this by tracking peculiar velocity, the essentially motion of galaxies relative to the cosmic expansion. If galaxies were just floating along with expansion, they'd all move away from each other at predictable speeds. But they do not. Look, galaxies near nihility move faster than expected, accelerating away from the empty regions. Honestly, galaxies near massive clusters move slower or eve toward the clusters drawn by gravity. Now, here's where it gets good. This creates a flowing form. Matter streams out of voids and into filaments. The fibril feed into galaxy bunch. The clusters turn heavy while the nihility turn emptier. While expanding the empty spaces between them, the universe is segregating itself, concentrating matter into smaller bulk. Current measuring show voids are expanding about 10% faster than the average cosmic expansion rate. Also, that might not sound like much, but compounded over billion of age, it's tremendous. A nullity that's 100 trillion light-years crossways today will be 200 million light-years across in 10 trillion years and 300 billion light-years across in 20 zillion years. The growth is exponential. This has terrorist implications for, the universe's long-term structure. Right now, matter is organized into a cosmic web. Filaments and clump divide by void. Definitely, but as voids expand, the fibril will thin. Galaxy bunch at the nodes of the web will merge into superclusters. Here's why this matters. Eventually, each supercluster will turn an isolated island of matter surrounded by an exponentially maturation void. the Lanius supercluster. Our cosmic neighborhood contains 100,000, pretty much, galaxies will eventually stand solitary. Every other supercluster will pull away beyond our cosmic horizon, carried away by the expanding voids between us. We'll be left with our local affairs surrounded by emptiness stretching in every direction, and it gets worse. Dark energy strength appears constant, import voids will never stop growing. The truth is, there's no equilibrium province where expansion and sobriety balance out. The nihility will expand eternally, growing fast as they get emptier. Let me put it this way. Here's the deal. The spaces between matter will turn so large that even light will struggle to cross them. Sometimes, think about what this agency for cosmic communication. Right now, different galaxy bunch can hush exchange information. Light source from one cluster can scope another in hundreds of millions of years. But as nullity grow, the distances increase. Eventually, light leaving one cluster will near reach some other. Not because the destination is receding too fasting, but because the vacancy between them is expanding faster than visible radiation can cross it. Also, each supercluster will become causally isolated, cut off from every other concentration of matter in the universe. There will be island universes, small pockets of construction floating in an infinite ocean of spread out emptiness. Any civilizations in those islands will look, out and see nothing but shadow. They'll have no evidence other superclusters exist. No way to communicate with them, even if they knew they were there. The thing is, we're witnessing the early stages of this fragmentation right now. Often, the voids we find today are the seeds of future isolation. Here's the deal. The emptiness growing between galaxy clusters is the get-go of a process that will ultimately separate the universe into countless unreachable area. Some scientists estimate we have about 150 billion LT before the voids spread out enough to isolate our topical anesthetic supercluster completely. Others conceive it could go on sooner, perhaps as soon as 50 billion years, depending on how wickedness energy posture evolves. Usually, either way, the clock is ticking, the voids are growing. No doubt, the existences had bent apart and there's nothing we can do to stop it. But the voids are not the only mystery eating away at the fabric of infinite. In 2004, astronomer analyzing the cosmic microwave oven background discovered something wrong. Think about it this way. Generally, most of the sky showed the expected form. Tiny temperature fluctuations about 2.7 deg above absolute nix, but one part about 10 deg across in the constellation Eridanus was diverse. Colder, about 70 microkelvin cold than the surround regions. That might sound tiny, 70 millionth of a grade, but at cosmic scales, it's tremendous. The cosmic microwave background is the most uniform thing in nature. Temperature variations are typically 100,000 multiplications smaller than what we see in the cold spot. This was not a small anomaly. What's more, this was a statistical impossibility showing up in our telescopes. Besides, scientists call it the CMB common cold spot. Now, here's where it gets good. And 13 years after its discovery, we still don't understand it. The simplest explanation is that it's just a random fluctuation. Probability says that even incredibly unlikely events should happen someplace in a large enough data set. Really, the problem, we've calculated the betting odds. The chance of a cold spot this large appearing haphazardly in, essentially, the cosmic microwave oven background is about 1 in 50,000. Possible but suspicious. Other explanations are stranger. Usually, one hypothesis advised the low temperature spot is caused by a supervoid, a region of infinite larger than we've ever observed, extending billions of light years across. Without question, as light from the cosmic microwave oven ground travels through this vacuum, it loses energy climbing out of the void's gravitative well. This shuffle the visible light appear colder in that direction. The number's almost piece of work. We do find an unusually large void in the direction of the cold place about 1.8 billion light-year crosswise. Basically, but when physicists calculate how much cooling that nullity should cause, they get a figure far littler than what we observe. In fact, the vacancy helps explain the coldness spot, but it's not the complete reply. A more disturbing theory, the coldness place is evidence of a collision, not between galaxies or even between galaxy clump, but between universes. If our universe is one bubble in an infinite multiverse, and if another house of cards once collided with ours, the impact would leave of absence a scrape, a region where the fabric of space was compressed or depleted. And here's the thing, the cosmic microwave ground in that area would look colder because vigor was lost during the collision. In fact, this sounds like science fiction, but the mathematics is sound. Multiverse theories that arise from cosmic inflation call precisely this kind of signature, a cold underdense part close to 10 billion light-years across appearing as a circular spot in the cosmic microwave ground. The coldness spot matches this prediction almost perfectly, Here's the bottom line. The implications are staggering. If the cold spot is a hit scar, it means other universes exist not as abstract mathematical possibility but as physical area of space that once touched our own. Surprisingly, it way our universe has boundaries, edges where it interfaces with other bubbles. It means reality is vastly larger and stranger than we always imagined. Generally, but we cannot turn up it. The cold spot sits at the edge of our observational limits. We see the temperature anomaly, we see the vacuum beneath it. We can measure and remeasure and analyze the data, but we cannot run experiments. We cannot visit the region and inspect it up close. We are restricted to interpreting photons that have been traveling toward us for 13.8 billion years. Some scientists rest skeptical. They point out that the cold place could be caused by foreground contamination, dust, or gas in our own galaxy blocking or scattering the background radiation. Or it could be an instrumental artifact, some subtle systematic error in how the satellite measured that patch of sky. These explanations are boring but plausible. Besides, the frustrating part is that basically we might never know for certain. Let me put it this way. The low temperature spot exists at the boundary between what we can observe and what we can explain. Here's the bottom line. It's either a random fluke, a super void, or grounds of a cosmic hit. Each explanation is possible. None is proven. Here's the bottom line. Interestingly, what makes the cold spot truly unsettling is not just its existence, it's what it represents. A reminder that the world can show us anomalies we're not equipped to understand. Patterns that break our models, mysteries that sit right in front of us, seeable in our best telescope and yet remain unsolved. And the cold spot is not even the strangest thing moving through infinite. On top of that, in 2008, a team of Uranologists noticed something impossible. They were tracking the motion of galaxy clusters using X-ray observations, expecting to see random movements in all directions. Or else, they found a pattern. Hundreds of galaxy clusters travel in the same direction, all of them flow like a river through space. Importantly, they name it dark flow and it should not exist. The thing is, according to cosmogony, cold-spot clusters should relocation randomly, pulled by nearby gravitative sources, but with no overall choose direction. The universe should look the same in every direction with no large-scale flow or currents. That's a briny rule called isotropy. Darkness flow break that rule. The clusters are traveled toward a specific point in the sky in the constellation Centaurus at speeds up to 600 m/s. That's over 1 million mph, and they travel coherently all in the same direction as if pulled by a single massive source. The problem, there's nothing in that direction, no supercluster, no strange concentration of matter, nothing visible that could ground such powerful attractive force. Scientists have scanned the region with every telescope available, optical, infrared, wireless, X-ray. Generally, they discover cold-spot clusters, sure, but odd special, nada that should pulling century of other clusters toward it. So, what's causation the flowing? What we're seeing is, actually, one possibility is that dark matter is distributed unevenly at scales larger than we've measured. Perhaps there's a massive concentration of invisible matter sitting just beyond our observable creation's border. Truth is, its gravity reach into our cosmic house of cards draw a galaxy bunch toward it. We cannot see the origin because it lies beyond where visible, radiation can range us, but we can see its gravitational influence. Obviously, some other hypothesis suggests the uniquity flow is remaining momentum from the universe's earliest moments. During cosmic inflation, the brief time period when space spread out exponentially right after the Big Bang, some regions might have inherited a preferred direction of motion. That movement persists today, carrying galaxy clusters along predetermined paths carved by ancient physics. The most unsettling explanation. Dark flowing is grounds of structure beyond our universe. Definitely, if the Big Knock create multiple cosmic bubbles, separate region of infinite with their own natural philosophy, then massive structure in neighboring bubble could exert gravitational pulling across the boundaries. So what does this mean? We'd see clusters in our universe flow towards something we can near observe, draw by affair that exists exterior our reality. What's more, this last possibility is deep troubling. It suggests our observable universe is not the whole tale. Besides that there are external forces acting on us from part we cannot see, cannot measure, and cannot ear visit. We're not isolate, we're not independent. Here's the deal, we're being influenced by something beyond our cosmic horizon. Generally, but here's where the controversy begins. What we're seeing is, not all scientists hold dark flowing exists. Some measurements sustain it, others do not see it at all. The effect is elusive. Measure galaxy cluster velocities is difficult, and small systematic errors can produce false signaling. Teams using alternative method get different results. Also, some see coherent flow, others see random motion. The debate has raged for over 15 age. Papers are published claiming dark flowing is real number. Counterclaim it's an artifact. The astronomy community cadaver split. Without consensus, dark flow exists in a strange limbo. Observed by some, denied by others, impossible to control conclusively. Also, what makes this frustrating is that dark flow, if real, would be profoundly important. It would show the observable universe isn't in everything. That structure exists at scale big than we can straight measure, that our cosmic bubble is embedded in something immensely bigger. These are core inquiry about the nature of reality itself. Often, yet, we cannot answer them. The grounds is right at the threshold, basically, of what our instruments can discover. Slightly improved measurements might sustain dark flow, or they might reveal it was a mistake. We're stuck in the worst possible position. Tantalizing hints of something revolutionary, but no way to turn up or disprove them. If dark flow is real number, it pales in comparison to the key job we face, and evening. The universe power be space and will only really ever see the tiniest fraction of it. Stand exterior this night and look up. Count every adept you can see, perhaps a few thousand on a clear night. Those stars are all inside the Milky Way. Our home galaxy contained 200 billion adept total. Now conceive bigger. Our galaxy is one of 200 billion galaxies in the evident existence. That's about 40 trillion stars that we can potentially observe. Sounds like a lot, doesn't it? Here's the devastating truth. It might be nothing. If the universe is infinite and the topper ground suggests it is, then the observable universe is in space decimally small fraction of what exists. On top of that, envisage picking one grain of sand from all the beaches on globe. Generally, that cereal is large proportionally than our discernible universe compared to in space cosmos. The question of infinity has haunted cosmologists since we number one understood the universe expands. If space extends evermore, then everything that can subsist does survive someplace. An infinite existence contains infinite galaxies, infinite stars, infinite planet. Somewhere out there, endlessly far away, isn't take duplicate of Earth, an exact duplicate of you reading these take words. In fact, there are infinite duplicates dissipate across infinite space. This is non-skill fiction. It's a logical consequence of infinity combined with quantum mechanics. Matter can only arrange itself in a finite number of slipway within a finite volume. Now, here's where it gets good. If infinite is infinite, every possible arrangement must repeat eventually include the agreement that's you, your living, your memory, everything. But we'll never see those duplicate, never put across with them, near Eve know they exist. Importantly, because infinity lies beyond our cosmic horizon, visible light from those remote regions will never scope us. The infinite between us expands fast than light travel. On top of that, while infinity stretches beyond in every way, we're restricted to our observable bubble about 93 billion light-year crosswise. The math here becomes disturbed. What we're seeing is, naturally, if the universe is infinite, then the observable world, everything we can ear, see, measure, or interact with, is exactly 0% of what exists. Not almost zero, not very small, literally zero. No matter how large a finite part is, its proportion of infinity is zero. What we're seeing is, think about what this agency for knowledge. We seek to understand the existence utilities a sample size of 0%. Imagine seek to comprehend human civilization by studying one bacterium on one person's finger. That bacteria has more info about humanness, pretty much, than we have about in space universe. Maybe we're lucky. On top of that, maybe we inhabit a distinctive area and the rule we notice apply everywhere. But maybe we're not. So what does this mean? Maybe the physical science in our region is unusual. Maybe other areas have separate brainy constants, alternative laws of nature, various types of matter. To be honest, if the world is space, anything that can happen does pass off someplace, include regions where physics plant completely differently than here. This creates something philosophers call the cosmologic horizon job. We can only shuffle statements about what we detect, but what we observe might not be representative. The existence beyond our horizon could be wildly distinct and we'd have no way to cognize. Our possibility might be right locally but wrong universally. Definitely, some physicists argue this makes the concept of the existence non-meaningful. So, what does this mean? If we can only observe one finite bubble, then that bubble is our total creation. Everything beyond it power as well not exist. It can near affect us. We can near bear on it. There's no causal connection whatsoever. Here's the bottom line. From a practical standpoint, the world is only the part we can interact with. But that feels unsatisfying. like denying that the moon exists when you're not looking at it. Plus, those remote areas are real number. They contain matter and vigor and be like life and certainly structure. They're not alternative universes in alternative dimensions. They're the same space, the same time, just unreachably far away. Calling them not our universe is semantic gymnastics to avoid uncomfortable infinities. The reality is we pin down in a bubble of cognizable space surrounded by infinite unknown infinite. We can study our bubble meticulously, measure its properties, map its structures, realize its evolution, but we'll be uncertain whether our conclusions apply beyond what we can see. Now, here's where it gets good. Clearly, this is the ultimate limitation of cosmology. Usually not engineering, not funding, not time, just the basic natural philosophy of causality and light speed. No matter how advanced our instrument become, no matter how clever our theories, we'll never observe more than a finite fraction of an infinite whole. We're like explorers on a sphere who've been told the creation might extend infinitely in every direction. Basically, we can map our local region, chart its features, grasp how it works, but we cannot know if the territory 1,000 stat me beyond looks the same or completely different. We cannot know because we can never go there. What we're seeing is the horizon living pace with us no matter how far we travel. But here's what's interesting. And as the existence go along expand faster, that view is then expanding with our exploration. And here's the thing, it's shrinking back toward us, hiding more of realness with every lost moment. Certainly, right now, as you hear these words, galaxy are vanishing, not dying, not exploding, simply crossing an invisible line beyond which their visible light can never reach us again. In fact, scientists have calculated the rate close to 20,000 galaxies per second slip beyond our cosmic horizon. Obviously, that's 1.7 zillion per day. The reality is 630 billion per year. Naturally, picture watching a time lapse of the night sky spanning billions of years. You'd see distant galaxies growing dimmer, redder, fainter. One by one, they'd slicing to inkiness, not randomly scattered disappearances. What we're seeing is, unit regions of sky would go wickedness as clump cross the liman together. The observable universe would shrink before your eyes. This is not theoretical. Its occurrence right now at a measurable rate. Clearly, urinologists track recess velocities, how fast galaxies are locomote away from us. When that velocity exceeds the speed of light due to cosmic enlargement, basically, the galaxy has crossed the point of no return. Any visible light it emits after that second will near bridge the growing gap between us. Conceive about the math. 20,000 galaxies per minute. Truth is, each galaxy contains an average of 100 billion stars. Besides, that means 2 quadrillion stars are crossing beyond our reach every single second. 2,000 zillion solar masses of matter. Planets, nebula, black holes, everything all become forever unobservable. Here's what makes this procedure so final. In fact, when a galaxy crosses the horizon, there's no reversing it. Cosmic enlargement is accelerating. Darkness energy grows strong. The galaxy does not slow down and impetus rear into view. It races away faster and faster, carried by space, expand at velocity no force in physics can defeat. Each vanishing galaxy takes its info with it. If intelligent life existed there, we'll never know. Clearly, if they build up civilizations, get word natural philosophy we have not learned, create art we can't imagine, all of it becomes permanently inaccessible, not engage away, not hide, merely beyond the orbit where information can ever traveling between us. The loss is non-symmetric either. When a galaxy crosses our horizon, we simultaneously mark theirs. Certainly, any civilizations there would ticker our milk like way fade and disappear. If they sent signaling toward us, those signals would never arrive. If we sent signals toward them, same result. The separation is common and absolute. Future astronomers will inherit a poorer universe. Let me put it this way, not because matter is being destruct really, but because the evident portion is shrinkage. But here's what's interesting. No doubt, in 100 billion LD, as mentioned before, only galaxies in our local gravitationally bound group will remain visible. Everything else will have crossed the horizon. The thing is, the sky will contain about 50 galaxies instead of 200 billion, but the operation does not stop there. Even inside our local group, some galaxy power eventually be forced away by tidal forces or luck gravitative interactions. Over trillions of years, the figure of visible galaxies could drop to 30, then 20, then 10. The evident world will get a small clustering of neighbors surrounded by absolute darkness. This creates a tragic scenario for knowledge preservation. Everything we learn about remote galaxies, their formation, phylogenesis, decease, applies to objects we can study now. Future civilizations will then have access to those same objective. They'll have to trust historical records claim millions of galaxies used to survive, but they'll have no way to verify those claims. No independent observations, no way to try out hypothesis against reality. Imagine being state that massive construction used to filling the sky, but you can only see empty infinite. Would you believe it? Or would you assume your ancestors were mistaken? And here's the thing, that their telescopes were flawed, that they misinterpreted what they saw? Future uranologists will look this exact dilemma. The creation is erasing its own chronicle not by destroying evidence, but by devising it unapproachable. Of course, every galaxy that crosses the horizon takes a piece of the true with it. Surprisingly, every star that goes away removes data from the cosmic disk. The creation is become unknowable, not because it's changing, but because we're being separate from it. And if dark energy continues strengthening, the separations will not stop with distant galaxies. Dark vigor is currently ripping the world apart at the large scale, separating galaxy bunch, expanding voids, pushing affair into isolation. But what if it doesn't halt there? What if dark energy keeps getting strong until it tears apart galaxy, then star, then planet, then molecules, then atoms, then Eve, the primary molecule that shuffle up thing itself? This scenario is called the Big Rip, and it's one of the most horrifying ways the universe could end. Here's why this matters. The hypothesis is simpleton but devastating. Actually, if darkness energy's posture increase over time rather than remaining constant, there will come a moment when its repulsive force overpowers every other force in nature, including the force that clutch thing together. Often, here's how it would unfold. Generally, right now, inequity energy basically only predominate at cosmic scale. Gravity still holds galaxy clusters together. Electromagnetic forces still bind atoms. Nuclear forces still keep protons and neutrons intact. Inequity vigor is too watery at small distance to affair. But if dark energy strengthens it, the repulsion grow exponentially. Eventually, it becomes strong decent to overcome gravity inside galaxy clusters. At that point, bunch tear apart. Galaxies that have orbited each other for billions of age are ripped away from each other and scattered into the expanding void. The timeline is impossible to predict without knowing exactly how dark energy, evolves, but physicists have run the numbers for various scenarios. Of course, in one model, galaxy clusters rip apart about 61 million age before the final end. Stars are torn from their galaxies about 3 months before the end. Earth is ripped from its orbit around our star about 30 minutes before the end. Then it gets worse. As dark energy goes along strengthening, it overcomes the electromagnetic forces holding molecules together. H2O breaks apart into hydrogen and oxygen. Rock crumbles into constituent atom. Your body, everyone's body, every living thing disintegrates into a cloud of individual atoms. This happens about 30 seconds before the end. But dark energy does not stop. Here's why this matters. It keeps growth strong, overcoming even the nuclear forces binding atomic nuclei. Atoms explode into protons, neutrons, and electrons. What we're seeing is, matter as we cognize it ceases to live. This happens a fraction of a minute before the final second. In the finish instant, dark vigor becomes so efficient that it tears isolated flesh quark and negatron, the main edifice blocks of matter. Here's the bottom line. Space itself might fracture. The cloth of world could rip like overstretched cloth. The truth is, the creation would end not in low-temperature silence, but in catastrophic disintegration where everything, topic, energy, infinite clips shreds into meaninglessness. The good news, this is probably not our hereafter. Most measurement advise dark energy strength is constant, not increasing. It's productive enough to expand space, but not powerful adequate to overcome gravity or electromagnetic force at local anesthetic scale. We appear to inhabit in a universe bearing toward heat death rather than the Big Rip, but probably is doing a lot of work in that sentence. We do not actually know what dark sip is. We can quantity its current effect, but we cannot predict its future behavior with certainty. Often, if darkness energy is the cosmogod constant Einstein proposed, it stays ever more constant. Look, if it's quintessence, a dynamic field that changes over clip, it could weaken, strengthen, or oscillate unpredictably. Some observations hint that dark energy might be getting stronger. If dark sip was weaker in the past and stronger now, the Hubble tension, the disagreement about how fast the universe is expanding could be explained. Here's why this matters. If that's true, extrapolating forward suggests continued strengthening, and continued strengthening leads eventually to the Big Rip. How long do we have? Frankly, Topper estimates put it about 22 billion age in the future if the Big Rip is real. The truth is, that sounds ilk forever, but pretty much, it's less than twice the current age of the existence. In cosmic terms, it's tomorrow. The Big Rip forces us to face up the fact that dark energy is not just pushing galaxies apart. It's a key force capable of overpowering everything else in physics. Right now, it's washy at small scales. To be honest, but if it grows strong, aught is safe. Not galaxy, not stars, not atom, not even the quantum field's underlying reality. We're living in an era when wickedness energy is still gentle, when its effects are scarcely noticeable in everyday living, but the universe is accelerating into an unknown future where that gentleness might not last. If we forfend the Big Rip, the spaces between galaxies are already emptying faster than we realized, and Maven shaping is die. Look, not just in one galaxy or one part, crosswise the entire universe. Uranologists have measured the rate at which new adept are quite born over cosmic story, and the peak is Arsus. The universe formed more ace 10 million years ago than it does today, and the rate is dropping. Here's why this thing. Galaxy do not appear fully organized. Often, they grow over billion of years, accumulating gas really in junk, igniting new stars from that material. In the early universe, galaxies formed rapidly because gas was abundant. Cloud of atomic number 1 and helium filled the space between young galaxies, ready to prostration into new structure. But as the universe expanded, that gas spread out, thinned, inequity energy pushed galaxies farther obscure, and the gas between them expanded with the space. Less gas agency, fewer opportunities for new galaxies to form. The raw material for cosmic construction is being thin crosswise, ever larger bulk of space. Stream measurements show the star formation rate has dropped by roughly 95% from its peak. The universe once created the equivalent of 10 new stars ilk our own every year. At the end of the day, now it creates less than one, and the decline is accelerating. This makes a disturbing timeline. Most galaxies in the universe have already formed. We're living in the era when the last generation of large galaxies is hush condensing from gas clouds. Usually, futurity gas will be too scattered, too thin, too scattered by enlargement to collapse into new construction. The census of galaxies we see today is fundamentally final. No new galaxy will generate in our topical anesthetic region. The Milky Way, Japanese Andromeda, and the few dozen other galaxies in our group. This is our permanent neighborhood. There won't be fresh additions, no new structures emerging from surrounding voids. The sky will contain precisely these galaxies until they finally merge or drift apart. But even existing galaxies are running out of fuel. Star formation requires hydrogen gas. Also, galaxies comprise reserves of this gas, but it's not unlimited. Every time a star ignites, it locks away atomic number 1 into helium and heavier elements through fusion. Some gas is recycled when stars die, but much of it becomes for good unusable, trap in white dwarfs, neutron star, or inkiness holes. Scientists estimation most galaxies will exhaust their ace-forming gas within 1 to 5 billion years. After that, no new star will form. Survived stars will burn through their fuel and die. Look, red dwarfs, the smallest, longest-lived stars, can burn for 10 trillion LB, but eventually, they'll go dark. The universe will enter what cosmologists call the degenerate era. Here's the deal, all pattern stars will have died. The truth is, certainly, the only visible light will seed from cooling stellar remnants. White dwarfs fade from white to orange to red to brown to inkiness. Even this dim visible radiation will finally neglect. Actually, in about 100 trillion years, the finale white dwarf will cool below seeable wavelengths. The existence will go really dark. Now, combine this with cosmic enlargement. Not only are galaxies running play out of gas to form new stars, essentially, but they're also being separated faster and faster by dark vigor. The infinite between galaxies grows. The void spread out. Thing concentrates into smaller, more isolated area while emptiness multiplies. This means the existence is simultaneously dying and airing apart. Generally, star or fade while the infinite they occupy grows. In the far future, the few continue glowing ember will be divided by nullity traverse hundreds of billion of visible radiation years. In fact, each ember will be alone in an expanding darkness too far from any neighbor to communicate or interact. The tragedy is that this was not inevitable. If dark energy didn't exist, galaxies would cluster closer together. New structures would continue forming as gravitational attractive force pulled matter together. Frankly, star shaping might retard but wouldn't cease entirely. Darkness energy changed that hereafter. Let me put it this way. By accelerating expansion, it ensures that matter spreads too thin for new structures to form. By pushing galaxies apart faster than soberness can pull them together, it guarantees increasing isolation. The universe is not just expand. Indeed, it's being actively sterilized of new growing. When A still form abundantly, we exist in the fertile era. When galaxies Galaxies hush cluster when the universe is still young enough to create rather than just decay, but that era is termination. The raw materials are running out. The spaces are growing too large. Let me put it this way. The cosmic garden is wilting, and the few islands of matter that remain will eventually merge into even littler, lonelier structures. Gravity is lose the cosmic war, but it's winning a few local anesthetic battles. While dark energy tears the existence isolated at large scales, our little corner of space tells a separate tale. The Milky Way and Lily of the Valley tree are actually moving toward each other at about 70 m/s. In roughly 4 trillion years, they'll collide. Do not panic. Importantly, galactic collisions are not like car crashes. Galaxies are mostly empty space. When two galaxies unite, their stars walk between each other with room to spare. Basically, the odds of any two stars actually colliding are astronomical, but their collective gravity will reshape both galaxies, stirring stars into new orbits, triggering bursts of star formation as gas cloud compress and light. The merger will take about 2 billion years from first contact to final combination. During that clip, the night sky from World will be spectacular. What we're seeing is, if Earth hush exists by then, Lily of the Valley tree will grow larger in our sky, finally spanning 6 multiplication the width of the full moon. Its spiral arms will distort and wrap about our own. Stars will be flung into massive tidal flow arcing crosswise the heavens. Finally, the two galaxies will settle into a single elliptic coltsfoot. Scientists have already named it Milometa. This new A1 galaxy will contain roughly 1 trillion stars and span about 200,000 light-years across. It will be the dominant construction in our local neighborhood, but the merger will not halt there. The local anesthetic group contains about 50 other galaxies, most of them small dwarfs. Let me put it this way, over the adjacent 10 to 20 billion LD, these will also merge into Milomea. The Triangulum galaxy will be absorbed. The large and small Magellanic clouds currently orbit the milk-like way will spiral inward and join the growing mass. Every gravitationally bound object in our region will eventually become part of one massive structure. On top of that, this operation is happening because graveness function on a separate ordered series and cosmic expansion. Inside Galaxy Clump, the gravitational attractive force between galaxies is strong enough to get over darkness Vigor's push. Obviously, objects bound together by gravity will stay together regardless of how fast space expands about them. Usually, think of it like a rope tying two boats together while the ocean current pulls them away from shore. The current pushes both boats, but the ropes support them close to each other. The distance to shore increases, but the distance between boats remains fixed. That's what's happening in the local radical. Here's the bottom line. But here's the critical portion. This only plant for structures already bound together. Galaxies outside our topical anesthetic group, are beyond gravity's reach. The space between us and them is expand too fast for gravity to pull them back. Often, they're not tied to our boats. They're drifting away with the current, accelerating into the distance. Plus, in 100 billion years, Milka will be smothered by darkness. Indeed, every galaxy outside our local group will have withdraw beyond the cosmic horizon. The Virgo clustering comprised thousands of galaxies will be gone. The Coma Clump gone. The Great Wall of Galaxies stretch hundreds of millions of visible light age gone. All of it pushed beyond the border of the observable universe by relentless expansion. Without question, futurity astronomers in Milometa will look up and see one galaxy, just one. What we're seeing is a monolithic elliptical structure containing about 1 trillion stars. They'll catalog those stars meticulously, study their orbits, step their belongings, and they'll see nothing else. No neighbor galaxies, no distant clusters, no cosmic web, just their galaxy environed by infinite emptiness. Interestingly, if other galaxies exist someplace in the darkness, but they'll have no evidence, no observations to confirm it, they power marvel. To be honest, the cosmic microwave background will be too dim to discover. The expansion of space will be too subtle to measure with only one coltsfoot visible. Of course, every piece of grounds that once turned out the big smash happened, that other galaxy exists, that the universe is vast and populated, all of it will have vanished. They'll look at historical records claiming billions of galaxies once filled the sky. They'll read about quasars and galaxy clusters and cosmic structure, and many will think it's myth. Because the sky they see shows only isolation, antediluvian stories that our ascendant told themselves to feel less alone. This is the ultimate irony of cosmic evolution. Gravity will pull our local matter together into a grand unified structure. Also, we'll have more stars in our galaxy than always before, more satellite, more potential for living and civilization. But we'll be completely lonely, cut off from the balance of the universe by an insurmountable wall of expanding space. Here's the bottom line. The universe is simultaneously concentrate matter and isolating it, building island while drowning them in an always growing ocean. In fact, and finally, even those islands will go dark. Fast forward 100 trillion years into the future. Earth no thirster exists, consumed by our star billion of years ago. The Milky Way and Andromeda have merged into Milka. Most stars have exhausted their fuel and die. The Coltsfoot is now a graveyard of stellar remnants. White dwarf, neutron stars, inkiness, holes, but some stars still shine. Red Nonus, the smallest, most productive star can burn for 10 trillion years. A few of them are hush flickering in the darkness. Though their visible radiation is dim, each one sit alone, separate from its neighbors by dozens of light years of empty space. The galaxy has become a sparse sprinkling of demise embers. Look up at the night sky from a planet orbit one of these finest stars. What do you see? Mostly blackness. The nearby stars are so syncope and so far isolated that they barely register. No bright constellations, no Milky Way band across the sky, just a handful of dim red points scattered across absolute darkness. Indeed, every galaxy exterior your own has vanished from view. Not just beyond the horizon. Even if they were hush-seeable, they'd all be dark anyway. Every other galaxy in the world faces the same fate. Star populations demise, visible radiation fading, structure collapsing into an expand void. Basically, the universe is entering the black hole era. This is the period when inkiness hole get the dominant construction. All the matter that didn't get locked into stellar remnants has collapsed into these gravitational singularities. Supermassive black holes at the centers of old galaxies contain billion of times the batch of our former star. Smaller black hole from dead massive star. The darkness. But even inkiness holes are non-eternal. But here's what's interesting. Stephen Hawking proved they emit radiation through quantum effects near their case horizons. This Hawking radiation is implausibly weak. For a black hole the flock of our former star, the temperature is 1/10,000,000th of a degree above absolute nothing. But over an incomprehensible stretch of time, black hole lose mass and eventually vaporize altogether. Also, small black holes vaporize fast and large ace. A black hole with the flock of our former star would take 10 to the 67 power age to evaporate. Honestly, that's a 1 followed by 67 zeros, far longer than the stream age of the world. Supermonolithic inkiness hole return even longer, 10 to the 100 powerfulness eld. While this evaporation unfolds, the creation keeps expanding. Certainly, the infinite between black hole grows, the remnant of galaxy drift further obscure. Often, dark energy continues pushing everything away from everything else. To be honest, the voids expand until they rain all of space. Finally, after clip scales so long that human minds cannot comprehend them, even the inkiness holes will be gone, evaporated into faint radiation that disperses through expand infinite. At this point, the universe contains only isolate particles, electrons, quite positrons, photon neutrinos separated by unimaginable distance. These molecule relocation through infinite that expands fast and they can always meet each other. This is called darkness era. Frankly, no stars, no black holes, no structure, just individual molecules scattered across infinite expanding space. The world has become as empty as it can perhaps be. The temperature approaches absolute zero. Zip spreads so thin that nothing interesting can always happen again. Honestly, the dark sky in this era, if anything existed to observe it, would be perfective blackness. Not the inkiness of space between ace where distant galaxies still reflect. Actually, not the blackness of a void smothered by matter. Absolute blackness, no light route any place, really not to see in any direction. The universe has become indistinguishable from non-existence. This is the hotness to cease, the final equilibrium state where randomness has maximized and nothing change any longer. Every molecule sits in its own causally disconnect region of space. Certainly, every photon has been extended to space wavelength. Honestly, every joule of useful energy has been dispersed beyond recovery. To be honest, the operation takes about 10 to the 120 power years. That's so far in the future that compared to the current age of the universe is ilk comparing the stream age to a second. In fact, we survive in the first moment after the Big Bash compared to this timescale. The era when the existence is still bright, really, and full of construction is extraordinarily brief. Future will be dark, empty, dead, not because something catastrophic happened. On top of that, because this is the natural end province of a universe regularized by expanding space and randomness. Indeed, the visible radiation and life we see about us now is a temporary aberration, a legal brief flash of complexity before the long shadow claim everything. And the darkness is when, because emptiness is what the universe prefers. Entropy always increases. That's not philosophy. It's the moment law of thermodynamics. One of the most briny rules in physics. Heat flows from hot to common cold, order become disorder, concentrated energy sprinkle. Nothing can stop this operation, nothing can reverse it. Naturally, and given enough time, it leads to absolute equilibrium where nothing changes anymore. The universe started in a province of incredibly low entropy. Right after the Big Bang, all thing and SIP were packed into a tiny, hot, dense province. This concentration represented enormous potential for change, for construction, for complexity, and immediately entropy began increasing. Interestingly, stars formed from cloud of hydrogen. They burned their fuel, converting ordered nuclear vigor into disordered hotness and light. That light spreading through space, growing ice chest and more dilute. The stars eventually died, departure nates dark remnants. Each measure increased total entropy. Indeed, life is the world's most impressive attempt at fighting randomness topically. Living organisms donjon composite structure by consuming zip and dumping waste heat into their surroundings. We decrease our internal entropy at the expense of increasing environmental randomness even more. We're not breaking the second law. We exploit temporary gradients in vigor compactness. But those gradients are disappearing. Stars are running game out of fuel. The temperature differences between hot and cold regions are diminishing. The universe is becoming more uniform, more spreading out, more equal in temperature everywhere. Clearly, and as it does, essentially opportunities for life to exist are vanishing. Life requires disequilibrium. Hot stars surrounded by low-temperature space, dense planets near empty void, chemic radiance that can be exploited for energy. These differences will not last. In trillions of age, all stars will be dead. All temperature differences will have equalized. The universe will reach the same temperature everywhere, just a fraction above absolute zero. This province's name hotness death, but that's misleading. The world will not be hot, it'll be common cold. At the end of the day, incredibly, impossibly cold. But more importantly, it'll be uniform. Obviously, no temperature differences means no energy gradients. Interestingly, no energy gradient means no way to do work, no way to build structures, no way to support life. Consider about what this agency for cognizance. No doubt, right now your brain operates by exploiting chemical gradients. Basically, sodium and potassium ions flowing across cell membranes create electrical signals. This process requires energy. Clearly, that vigor comes from food, which in the end come from stars via photosynthesis or other mechanisms. Actually, without without energy gradient, consciousness becomes impossible. Of course, the existence will contain particles, photon, electrons, neutrinos, but they'll be so spread out, moving through infinite that expands so rapidly that they effectively never interact. Honestly, each corpuscle exists in its own isolate bubble of space, separated from all others by distance that light can never cross. In this state, time turns meaningless. When not a change, when no events occur, when more or less no interactions go on, time still technically passes. Often, also, there's no way to amount it or experience it. The world get into a timeless void where the distinction between one moment and the next disappears. Clearly, some physicists speculate about ways life power persists even this era. Mayhap advanced civilization could harvest vigor from inkiness whole evaporation. Possibly they could retard their metabolisms to infinite decimal rates, thinking every trillion old age. The thing is, mayhap quantum fluctuation in the vacuum could render microscopic amounts of usable energy. But these are desperate speculations. The math is clear, entropy ever increases. Vigor always disperse, and the end province is always equilibrium. The universe is marching inexorably toward a condition where living, any kind of life, any form of complexity, any structure, whatever, turn physically impossible. The timeline is so immense, it's almost comforting. What we're seeing is, indeed, heat expiry lie 10 to, essentially, the 1 to 100 power age in the future. Manhood will be long extinct by then. Our ace will die in only 5 billion years. Flush, if we somehow survive spreading crosswise the galaxy, engineered ourselves into form we saw and imagine, we'd still look the same end. But here's the existential free weight of it. We exist in a universe that's dying. Not chop, not dramatically, but inevitably. Every star that shines brings the universe closer to common cold darkness. Every coltsfoot that forms uses up energy that can never be recovered. The process that creates us is the same operation that will end everything. And the reason for all this to cease, emptiness, is simply what space wants to be. Matter is the exception. Space is the rule. Naturally, for every atom in the existence, there are billions of cubic light years of empty vacuum. We live on a dense rock orbiting a nuclear furnace surrounded by other atoms. So we consider thing is normal. But step back and look at the creation as a whole. We're island of complexity in an sea of nihility, and the ocean is winning. Physical science explains why. Creating topic requires energy. Soon after the Big Bash, temperature were so high that energy could spontaneously convert into speck antiparticle pairs. Quarks and antiquarks popped into beingness, collide, annihilated, rear into energy. Naturally, the universe was a sing soup of molecule constantly appearing and disappearing. As the universe expanded and cooled, really, this process slowed. Often, finally, really temperatures dropped below the threshold where new particles could form. Most topic and antimatter annihilated each other, leaving only a tiny excess of matter, about 1 particle per billion, that existed originally. That tiny excess became everything we see today. The residue become photons. Empty space contains about 400 photons of cosmic microwave background radiation per cm. Sounds like a lot, but these photons carry nearly no energy. Their temperature is just 2.7 deg above absolute zero. They're the leftover heat from creation, chill and diluted by enlargement. Let me put it this way. Meantime, infinite itself support ontogeny. Every moment, billions of cubic kilm, of new void appear end to end the world, not appear as in created from null. Infinite does not piece of work that way. The exist infinite stretch, expanding the distances between objects. As it does, the denseness of everything drops. Matter spreads thinner, energy disperses, the universe becomes emptier. This is the natural trajectory. High energy states are unstable. They decline into lower zip states. Concentrated affair is impermanent. It scatter under the influence of randomness and enlargement. To be honest, empty space is the stall's configuration, the state toward which everything trends. Even the quantum vacuum is not really empty. Plus, molecular antiparticle pairs still pop into creation briefly before annihilating. These virtual particles exist for time spans so short that Heisenberg's uncertainty principle allows them to borrow energy from nothing. But they do not last, they con and accumulate. The vacuum remains basically empty. Iniquity zip reinforces this trend. It's the creation's way of maintaining emptiness. Any region that become too heavy experiences gravitational attractive force that pull topic together. But dark energy pushes back, kind of, expanding infinite, diluting the density. It's ilk a spring that resists compression. Surprisingly, try to concentrate matter too much and cosmic expansion pushes it apart. The event is a universe where structure is impermanent and emptiness is permanent. Galaxies exist for trillions of years, but that's not a compare to the age the universe will finally reach. A shine brightly but in brief before cooling into shadow. Black holes evaporate finally, leaving behind only empty, infinite, and syncope radiation. Think about the ratio. The universe will drop its number 1 few hundred million years in the stelliferous era, the age of stars. No doubt, after that, it enters the black hole era, lasting until about 10 to the 100 power years. Then the dark era endure essentially forever. If the existence's lifespan were compressed into a single 12-month, the age of stars would last less than a millisecond, a brief flash at the outset. Everything after would be darkness and, kind of, spread out emptiness stretching on indefinitely. Surprisingly, we live in that opening flash, the exceptional moment when concentrated matter and vigor form complexity. This raises uncomfortable questions about meaning and purpose. If the universe's natural provenance is empty, dead, dark, what does it mean that we survived during the anomalous phase? Here's the deal, are we just a temporary accident, a legal brief variation in an otherwise eternal nullity? Physics doesn't answer those questions, it just describes what's unmistakably is that emptiness wins, construction is temporary, complexness is fragile. Here's the bottom line. The organized state that allows stars and galaxy and life to exist are fleeting aberrations in a universe that prefers nothingness. We're not living in the universe's peak. We're living in its infancy, the chaotic early era before it settles into its final exam province. Frankly, everything we see, everything we are is built from borrowed time. The universe is slowly, inexorably returning to the emptiness from which it emerged. What's more, and we're witnessing that process blossom right now in this brief golden age when emptiness has not yet consumed everything. 13.8 trillion years. That's how long the universe has existed. Let me put it this way, it sounds ancient. It sounds like forever, but compared to the clip scales ahead, it's nothing. The world is an infant, a newborn barely out of its first breath, and we subsist in the nursery. The warm, bright, active form before the long, cold adulthood begins. Right now, about half of all the stars that will ever exist have already formed. The other half are still being born or waiting to ignite from gas clouds. We're life through the, more or less, prime of cosmic star formation at the end of the day. This is the era when galaxies shine brightest, when stellar light illuminates the most space, when the universe is most alive. In some other 5 trillion years, most stars will have died. The last red dwarfs will still burn but dimly. The universe universe will be darker, empty, cold, but construction will still survive. Galaxies will hold together. Black holes will still orbit each other. It won't be dead yet, just declining. In 100 trillion LD, even the red dwarfs will go dark. The last normal stars will have exhausted their fuel. Let me put it this way. Only prima remnants will stay. White dwarfs chilling toward absolute nix. Neutron stars spinning lone in the darkness. Black holes evaporating imperceptibly. Look, the age of stars will be over, but the creation will have trillions upon trillions of age ahead. The clip between now and the end of ACE is shorter than the clip between the end of stars and the evaporation of the finished black hole. We exist in the gap paragraph of a story that will take eternities to tell. Think about what this means. Every ace you've always seen, every galaxy in our telescopes, every construction we contemplate, massive and aeonian, it's all temporary. In fact, humanity has existed for about 300,000 LD. The dinosaurs lasted 165 million LD. The oldest fossils on Earth date back 3.8 billion years. These clip spans appear enormous to us, but they're microseconds in cosmic time, less than a blink. Now, here's where it gets good. Here's the deal, the universe will exist for tenor of trillions of years after our star dies. For 10 to the 100 power age after the last black hole evaporates. For essentially forever after that, expand and cooling and emptying indefinitely. When matter organizes into stars and planets and life is a fleeting anomaly, the complexity we experience, the legal brief era. This is both depressing and profound. Think about it this way. Depressing because it agency, everything we are, everything we build, everything we accomplish is cosmically insignificant. The universe doesn't care about man's civilization. It does not aid about Earth or, more or less, our star or even our galaxy. We're temporary patterns in matter that will dissipate and fade ilk foam on in space ocean. Because it make this moment precious, but it's also profound. When the universe is knowable, we live during the only era. When stars shine bright enough to see. When galaxy cluster finesse enough to detect. The reality is, in fact, when the cosmic microwave background is detectable. Future civilizations will none have access to this richness. Look, they'll inherit a dark, hollow, alone cosmos. We're too lucky decent to exist when intelligent living can thrive. What we're seeing is, stars render energy. Planets provide stable environments. Heavy constituent fortunes supernovae provide the building blocks for complex chemistry. These conditions won't finish forever. Think about it this way. As we know it, finally, the universe will become too diffuse, too cold, too empty to support life. Some scientists call this the Goldilocks era. Surprisingly, when the universe was too hot and disorderly, and not too late when it will be too cold and empty, not too early. We're living in the middle ground when everything is just right for stars, planets, and consciousness to exist. Futurity percipient looking rear at our era will see it as the golden age. Also, the time when the world was young and vibrant, when galaxies make full the sky, when stars burned bright, when complexity flourished. They'll study the dodo record of cosmic history and wonder what it was ilk to dwell during manhood's clip, and they power envy us, at the end of the day, not because we achieved anything special. Here's the bottom line. Usually we likely won't survive hanker enough to topic on cosmic scales, but because we got to see the universe in its prime. We got to aspect up at a sky full of galaxy and marvel. Actually, we got to discover the big knock, measure cosmic enlargement, map the major scale structure. We got to be astronomers during the age when astronomy was still possible. The existence will not be this comprehensive, this bright, this knowable ever again. But here's what's interesting. It's emptying, darkening, spread out into obscurity. And we're here to witness it, to papers it, to understand it before the knowledge becomes unreachable. The reality is, this is our cosmic responsibility not just to ourselves or to humanity but to the future. Usually we must record everything we learn, preserve everything we discover, because civilization that seed after us won't be capable to verify it. No doubt, they'll have to trust our observation or remain ignorant of the universe's true nature. And what we've observed, what we've learned in these legal brief moments of clarity is terrorize. Here's the verity we've been circling about. The emptiness is not coming someday. It's not a distant future job. It's happening right now, every second as you learn these lyric. Naturally, the universe is disappearing before our eye, and there's nothing we can do to halt it. 20,000 galaxies per second crossing beyond our cosmic purview. 2 quadrillion stars per second becoming eternally unobservable. Voids expanding faster than light can cross them. At the end of the day, dark energy rupture space apart at accelerating rates. The operation is not wait. It's active, fast-growing, unforgiving. Every photon arriving at our telescopes is older than recorded human account. We're not seeing the universe as it is. We're eyesight its ghost. What we're seeing is, in fact, shadows of what survived billions of years ago, and those shadows are fading. The galaxy that emitted the light we observe tonight have already receded beyond reach. Frankly, while their present vanishes into inaccessibility, we're seeing their past. This creates a haunting realization. The existence we explore is already gone. When we point our telescopes at distant galaxy and marvel at their beauty, we look at structures that no longer exist in the form we discover them. They've evolved, changed, or receded so far that light traveling at maximum speed and keep up. We're cosmologists perusal a dead patient, role, examining memories instead of world. And it's getting worse. The charge per unit of galaxy disappearance is accelerating. Dark energy grows stronger or at minimum maintains its strength while the existence expands, give it more space to thrust against. Every year we lose more galaxy from view than the year before. Here's why this matters. The observable existence is shrinkage faster now than it did 1 billion years ago. Conceive about the entailment. Future astronomers will have less data than we do. To be honest, less discernible sky, fewer galaxies to study, less evidence of the Big Bang. Every cohorts of scientists will inherit a poorer, more limited view of reality. Plus, knowledge will none accumulate, it will erode. This is why we see so much urgency in modern cosmology. Scientists rush to map the existence, step everything observable, catalog every galaxy inside reach. Frankly, not because we're curious, though we are, but because we're running game out of time. The universe is revealing its arcanum during a narrow window, and that window is conclusion. If we do not document what we can see now, that information is lost forever. But documentation is not the same as understanding. We still do not cognize what dark figure is. We cannot explain why the universe is accelerating. We do not comprehend the full structure of reality beyond our cosmic horizon. We're watching something catastrophic unfold without comprehending the mechanism. Envisage being the finale, someone to see an endangered species before it goes extinct. You take photographs, platter observations, preserve samples, but you do not know why it's died. You do not cognize how to halt it. You're just witnessing extinction in real clip, helpless to intervene. Sometimes, that's humanity's relationship with cosmic expansion. The universe is teaching us a brutal lesson. Impermanence, nothing lasts. Look, not stars, not galaxies, not even the capacity to discover them. The universe we populate is temporary. Plus, the gnosis we gain is impermanent. The very fabric of space that permit thing to exist is temporary, eventually tearing isolated into isolation so complete that even particles get forever separated. And we're complicit not, through action but through existence. What's more, every second we live, entropy increases. Obviously, every maven that shines depletes its fuel. In fact, every observation we shuffle documents something that's already modified. We can't freeze time. We can't preserve the universe in its current state. We're passengers on a train heading toward darkness. Observation, the landscape fade from vista through the windows. This is the terrorized solution to why space looks empty. It's not just empty, it's being actively emptied. Dark energy is draining the universe like H2O from a bathtub. The voids are expanding like infected wound. Think about it this way. The galaxies are flee-ilk refugees from an unstoppable disaster, and we're witnesses to cosmic evacuation. The universe is not winding down gently. It's fragmenting violently. Indeed, structures that should be eternal are being ripped apart on timescales short than we expected. The emptiness is not patient, it's hungry. It consumes space faster than light can fill it. It swallows galaxies faster than we can catalog them. It erases grounds faster than we can preserve it. We survive in the brief window between creation and oblivion, between the Big Bang's violent beginning and the hotness death's silent termination. That window is shrinkage. The world is less knowable today than it was yesterday. Less observable, more isolated, more alone. This is why space looks empty, because emptiness is winning. Because the universe's natural state is void, and we're watching it return to that state in real time, at the end of the day. Without question, because every moment that walk takes us one step finisher to a future where nothing exists but low temperature, iniquity, isolated particles float through infinite expanding infinite. Certainly, the terrifying truth is not that the universe will end someday. It's that the ending has already begun. The countdown started billions of years ago. The process is unstoppable and we're living through it. Observance, everything we can see disappear into shadow that swallows ace, fundamentally devours visible light and erases reality itself from observable beingness. The universe is telling us something through its emptiness. Everything ends. But here's what's interesting. Often, and right now, this very moment, we're